Good afternoon, students. Good afternoon, students. In yesterday's class, we were discussing about structures. Can you able to see the screen, PPT screen?
Yes, ma'am.
Yeah, yesterday's class, we were discussing about structures and nested structures. And we saw the example program also. So in this nested structure, we have one structure called employee. Within the employee, we have ID, name, and salary. And we have one field called address. This address is again an structure type, struct address, add. So here the address structure is defined as with three fields: house, city, and pin code. So while accessing the nested structure here for employee, we creating the member called E, and for the address we created the member called add. So while accessing the address, we have to say E dot add dot house number, E dot add dot city, E dot, because the member of employee is E. The same way, while accessing the pin code, we will use E dot add add dot pin code. So using the dot operator, we are accessing the members of structure. The same way as structures, we have another concept called unions. Structures and unions both are same, will have the same syntax for initialization, declaration of members, and accessing the members. Syntax and semantics, everything is same. The only difference between structures and union is, for structures, individual memory space will be allotted for each and every structure member, but for union, only one memory space with the highest value of the data member will be allotted. The same memory space will be used by all other members. Say unions are user-defined data types. Syntax is as follows. We will use the keyword union followed by union name within opening and closing bracket semicolon. We will have data type followed by variable name, comma, the n number of different types of variables. Say here we are creating a student union. Union student within opening and closing brackets, int ID, character name of 20 and float percentage. For integer variable ID, 2 bytes will be allotted. For the character name, 20 bytes will be allotted because character takes 1 byte. 1 into size of the string is 20. So 20 into 1 byte, 20 bytes will be allotted. Float is 4 bytes will be allotted. Here, which variable is having highest memory location? ID takes only 2 bytes, name takes 20 bytes, and percentage takes 4 bytes. So for the whole union student, 20 bytes will be allotted. While reading the value of ID, in the same 20 bytes, ID will be stored. While reading the value of name, 20, all the 20 bytes will be used. While storing the value of percentage, 4 bytes will be allotted. All elements can be processed, cannot be processed at a time. Stored the elements individually and shares the same memory location. So we can store the elements separately, but they all share the same common memory location. So the only difference between structure and union is structure takes individual memory location for all its elements, and union takes store the elements individually and shares the same common memory location. So that is the only main difference. Say for example, if you take the, we are creating an program to explain the unions. Here we are taking union, uni. So the uni is our union variable, and within the union we have short integer A, short integer B. So short integer means they will take 2 bytes. Within the main program, we are creating union uni, a variable is created. So where through the variable union variable member var dot a, we are storing the constant value as 10. Printf var dot b. So what it will display? It will display the value of 10. And variable dot b equal to 20, we are displaying the value of a. So the same memory location, we are storing both the values. So when you say where dot b, we store the value as 10 for a only, but if you print b, the same value will be stored in b also. So it will display variable dot b is 10. Then we are changing the value of variable dot b equal to 20. So now we are displaying the value of variable dot a. It's displaying the content of variable b, because variable a and variable b both share the common memory location. So if you take the main difference between structures and unions, so the keyword struct is used to define a structure. Here in structure, we'll use the keyword struct followed by structure name. In union, the keyword union is used to define the union. So we'll use the keyword union followed by union name. When a variable is associated with a structure, the computer allocates the memory for each member. The size of the structure is greater than the or equal to the sum of the sizes of the members. So for each and every member, a separate memory location is allotted. Size of the structure will be addition of all the members' memory location. When in case of union, a variable is associated with a union, a compiler allocates the memory by considering the size of the largest memory. So we will find out the variable which is having the largest memory in the union. The size of union is equal to the size of the largest number. So only one variable within the union which is having the largest size, that much amount of memory alone will be allotted. The same memory will be used by all the union members. Here, each member with the structure is assigned a unique storage location. So each and every member of the structure will have its own unique storage location. In case of memory union, memory allotted is shared by individual member of the union. So the same memory location will be used by all the members of the union. Say in a hostel, if you are staying in an individual room, then it is the single person will occupy the complete room. But if you take, if it is a shared room among the two or three students, so the same room will be used by all the people. Arranging the value of member will not affect other members of the structure. So if you change the, or if you do any manipulation with the union structure members, that will not affect other members of the structure. Allotting the value of any one of the member will alter the other members of the value. If you do any modification in content of any one variable, that will affect the other members content, because the same memory is accessed by all the members. Individual member can be accessed at a time. So at a time, we can access any member from the structure, and only one member can be accessed at a time. In case of union, only one member we can access. So if you want to access the next memory, then the same memory will be accessed by the other members. Several members of the structure can be initialized at once. So in structures, we can create n number of members. Say struct student S1, S2, S3, up to S100 or something. But in case of union, only the first member of the union can be initialized. So in case of union, we will initialize only one member. After completion of the process, we'll go for the next member. And the same, and the next member also, union 2 member also, will use the same previous old memory location. So that is the main difference between structure and union. So any doubt with respect to structures and union? Say for example, if you like to know the main know the main difference. So in this, I added few more slides. Can you able to see the PPT screen?
Yes, ma'am.
The PPT is visible to you. PPT is visible.
Yes, ma'am, it is.
Yes. If you take to know the main difference between structures and union, say you are creating a structure data member. So memory allotted for the structures member is total structure is student structure is 48 bytes. How the 48 bytes will be allotted divided among all the structure members means, say the structure student is having name, 40 bytes will be assigned to the name, and the roll number 4 bytes of float type, and phone number of 4 bytes of float type, and here name of 40 characters. So if 48 bytes is allotted to the structure, for name takes 40 bytes and roll number takes 4 bytes and phone number takes 4 bytes. But if you create a structure of student, in this case the same variables we have, say it is a structure student with the name, roll number and phone number. We are creating union student with the same name, roll number and phone number, but out of all the three members, the name needs 40 bytes. For union only 40 bytes will be allotted. The same 40 bytes, name will be stored, roll number will be stored. When storing name, name alone will be available. When you want to store, read and display the content of roll number alone will be stored. And if you want to store the phone number, the same memory location 40 bytes, the phone number will also be stored. So the common memory space 40 bytes, the member which is having the highest memory location, name alone will be allotted memory. In the same memory 40 bytes, we can store roll number also, we can store the phone number also when we are doing some process. Say the second example shows you, say here we are creating structured student with the variables A, B, C. So separate memory will be allotted for 1 byte will be allotted for say A will take 2 bytes because integer float, B will take 4 bytes because float type, and C will take 1 byte because it is character type. Separate memory locations will be allotted. So the total number of bytes we need is 1 plus 4 plus 2, we need 7 bytes. But if you create union variable UU with the same variables A, B, C, here what it will do, it will allot only 4 bytes because the float B needs 4 bytes. The same float B 4 bytes, while storing B, it will take all the 4 bytes. And while storing A, it will take only 2 bytes. While storing C, it will take only 1 byte. So only 4 bytes will be allotted, and the same memory location will be used by all the union members. Okay, in this example also you can easily understand we are creating a structure called employee with X and Y, two variables. We have a member, structure member E. So here character 1 byte we need and float 4 bytes we need. So totally 5 bytes will be allotted. So the variable X will be stored in its own place, Y will be stored in its own place. But in case of union, say it will allot only 4 bytes, not 5 bytes. So in the same memory location 4 bytes, when reading and processing X, that will be stored, and while reading and processing Y, that will be stored. So here it will allot only 4 bytes. Here it will allot 4 bytes for Y and 1 byte for X. So here individual memory locations will be there, and the changes in one memory location, one variable content will not affect others because they are separated. They have their own unique memory locations. But here union, it is a common memory space with maximum size. The same space will be used by all the members of the union. You got the idea? Got the idea? Any doubt with respect to structure and union? From the figure, you can easily understand. You got the idea? Any doubt? The PPT screen is visible to you all?
Yes, ma'am.
Yeah, if you take the next concept in our C, we have variables of types of variables in of storage classes. So far we discussed the basic data types like integer, character, float. Within that we have two more types, signed, unsigned, and the same way we have short and long. Then we studied about the user-defined data types like arrays, structures, unions, strings, and the pointers, double pointers, nested structures, so all those things. The same way, we have other unique data types or storage classes or memory locations where we can store variables and constant values. So we have different types of variables of storage classes. Here the storage class, in the sense, it means storage means memory, and classes means we have different types of storage, storing of variables. So what are they means? We have some keyword based or some unique register, auto, static, dynamic, extern, those kind of keywords we will use in C programming. Those keywords used along with variables represents they are special kind of variables. So the keyword static means it is a constant one, and it may be varying size or in varying size, or it may be dynamic one, and the scope, lifetime, and all those things will be fixed based on the keywords. The concept that describes the variable storage part can be referred to as storage classes. So we can have different types of variables. Variables means that their value will change during the processing, and we can make the variables as some special kind by using some keywords. What are they means? Every variable can have storage class to decide the below parameters. So based on the three parameters, scope, lifetime, and a default initial value, we can say whether the variable is a static variable or a external variable or auto variable or register variable. Say whether the variable is global or local, and its lifetime is also determined by using the storage classes of C. If you say a variable is global, the variable will be declared above the main program, and that will be used by the main program as well as in the functions. If you say a variable is local, the variable will be declared within a for loop. Its scope will be within the for loop alone for int I equal to. So the variable I will be used within the for loop alone. Once you come out from the for loop, the variable is unknown. The same way, we can have within the function, we can create our own. Within the function, after opening and closing brackets of the function, we can have our own variables. The lifetime of the variables will be within the function alone. So those variables are called local variables, and its lifetime is also determined by the storage class in C. So this storage based on the scope. Scope means how long it is visible, how long we can make use, whether it is use and throw, or it's for 1 week, or we can use it for 10 times, or its lifetime is we can store it in file, means it will be preserved for a long time, or once you come out from the function, it the variables will be destroyed, or if you once you come out from the main program, the variables will be automatically, memory space will be reallocated. So the scope, lifetime, and its initial value. If you assign some initial value, the value it will take. If you won't assign any initial value, the default initial value will be 0. So like that, we can, based on the scope, lifetime, and default value, we can categorize the variables as global variables or local variables by using the following 4 types. So what are they means? Say the variables, types of variables can be categorized based on the storage classes in C programming. We have auto or automatic variables, which is by default. If you won't use the keyword auto, it means the variables are automatic variables, or the default storage class is auto type. Say if you say int x, so here where x is by default auto type, or if you want to make the variable x as extern type, we need to mention extern. Or if you want to make the variable as static, constant one, we'll use the keyword static. If you won't mention anything, by default, it is auto type or automatic variable. The second type is called extern, external variables that are defined in another file in a project folder. Say if you are using files, and if you want to use the variable in your main program as well as in function as well as in the files, in that case we can mention the keyword extern before the variable name. And if you say static, the static variables are keep track of the changes in the value of variable inside the different blocks. So if you use the keyword static, it means the variable is a static variable, the scope of the variable is within the block alone. And we have the fourth type called register. register variables that are stored in processes. So within the C compiler, within the processor, we have registers like A register, B register, C register, D register. A register means accumulator register, B register means base register, C register means counter register, D register means data register. So the same way we have higher order AL, AH, BL, BH, CL, CH, and we have counter register and we have program counter. So we have some registers. So if you do the process by making use of registers, the speed and efficiency will be very high. It's like using the RAM memory space. So based on the types of variables, we can classify the storage classes in C as auto variables, external variables, static variables, and register variables. So these are the for storage classes in C. So how the storage classes will be declared means we'll use the same syntax, data type followed by variable name, comma. Say here if you say int A means it is normal integer variable. If you say auto int means it is an automatic variable. So the storage classes will be specified before the data type. So we'll specify the storage class followed by data type followed by variable name. So if you say auto int means the variable A is automatic variable of integer type. If you say extern int A, then the variable A is of external variable. The external variable's lifetime is throughout the program. It can be used in the main program. It can be used in the functions. It can be used in the files. If you say static, the value is static or constant one. It will take the constant value throughout the process. And if you do any changes to the static variable, the scope will be within the block alone. And if you say register int A, the variable A is of register type. The value will be stored and processed within the registers, program registers. Say how we'll make use of these things means. So we can categorize those variables based on the declaration location, scope, visibility, and lifetime. So this I have added for your understanding purpose. So if you use the storage class as auto, it will be declared inside the function block. And within it will be visible within the function block alone. Function block means within the function, within the for loop, within the while loop. And the lifetime will be once you come out from the block, it will be destroyed or it will be reallocated. And the register means inside the function or block, the visibility also within the function, and lifetime also within the function or block. Once you come out from the for loop or while loop or any function block, it will not be visible. It will be destroyed. If you take extern outside all functions, if you declare the variable as extern int x, the variable can be used in main program, can be used in the functions, can be used in a number of all functions belongs to the same C program. Entire file plus other files where the variable is declared as extern until the program terminates. The variable will be available from the main program to all functions to the files. Once you come out from the main program, if you complete the process, then the content will be destroyed. Static local variable means inside the function block, and within the function block, scope will be within the function block, and the lifetime is also within the program. Once you terminate from the program, exit from the program, it will be deleted. And a static global variable means within the function and outside all the functions also. And scope will be within the file, within the main program as well as in the functions. And lifetime is once you come out from the main program, it will be destroyed. So by using those understanding, you can easily understand how we can make use of auto variable. Say a variable that is defined inside any block. Say the block means a function code or any for loop or any processing block, opening and closing brackets, or without the keyword auto or automatic variables. So if you won't specify the keyword auto, by default it is automatic variables. If you say int x or int p or int roll number, by default it is an automatic variable. Or if you want to mention it is an automatic variable, you can add the keyword auto also. Both int a and auto int a both are same. The auto keyword is default. Both are automatic variables only. Automatic means those variables gets memory allocated inside the the beginning of the block, and gets memory deallocated once you close the block. And end of the block, the variable is not visible to other parts of the program. So this is about automatic variables. Say for example, they given you an program int main. We have a variable int I1 automatic type. The initial value is 1, and within the block we are using others. We are using the same variable, reassigning the variable auto int I1 equal to 2. So the current value of I1 is 2, and within this block we are saying I1 equal to 3, reassigned. Then we are saying print the content. Now the value of within this block, the value is 3, so it will display 3. And once you come out from this block, it will go to the scope of the block is this. Here the value of I2 is I1 is 2, so it will display 2. And we are coming out from this block, the block is closed. Then the third block, the scope of the value is I1, so it is displaying 1. So within this block alone, the value is 3. In the second block, outermost block, value is 2. The outermost block, the value is 1. Innermost block 3, outermost block 1. In between, the value is 2. So in this example program, we have same variable name I1 declared in 3 different blocks. But having the same name for multiple variables in the same block, it is not allowed. It is an error. Hence, we have 3 definitions for the variable I1. So that's what each and every time we are redeclaring. So within this block, the I1 is declared. So we are saying int I1 because here itself we are declared int I1. So no need to declare here, no need to declare here. But each and every time the variable is reinitialized. So within this, we are initializing the value as this. And once you come out from this, the variable is unknown. And within this block, we are reinitializing. And within this block, we are initializing. So if you execute this program, it will show you the result as screen is visible to you.
No, ma'am.
Yeah, I'm sharing the program. So the screen is compiler is visible.
Yes, ma'am.
Yeah. So we have taken the program for auto example. We have main program. We initialized auto int I equal to 1. So this is our outermost block. And we have once again we are declaring 2. Once again we are declaring 3. So this block starts here and this block ends here. So while executing this, it will display 3. And the next block it will display 2. And the next block it will display 1. Because the auto variable scope is within from this to this. And from this block to this block, the value is this. And the outermost block, the value is this. So if you compile and run the program, it will show you the result as 3 to 1. So wherever we use auto, it means the variable is visible. Visibility is within this opening and closing brackets. Lifetime also within this opening and closing bracket. And it will be available within the opening and closing brackets. So it is local variables. The same way we have the PPT is visible to you.
Yes, ma'am.
The same way we can we have auto variable. The lifetime is within this block. And if you take the variable as extern type storage class, the extern specifier gives the declaration variable external storage class. So it is external storage. When extern specifies is used with a variable declaration, then no storage is allotted to that variable. So separate memory will not be allotted. The principal use of extern is to specify that the variable is declared with external linkage elsewhere in the program. So the variable is already declared and defined, and its value is available somewhere else. From that location, we need to access. It means that it's not part of the program. The variable is already declared and defined. It's available in some other block of the program. From there to here, we are accessing it. We are reusing the extern variable from some other block. Say how it can be, how we can make use of the extern variables in our program means, say here we have extern int x. Here we are using a variable int x. Its storage type is extern type. It means the variable is declared and defined somewhere else. So in the main program, what we are doing, printf x. So the old value of x will be printed, get x, and so it will display. If you change the statement extern in the int x to extern int x equal to 50, you will assign, get the error message, because it is a redefinition of the x variable. Because the variable is declared and defined, its value is assigned by some other program. From that program to this program, we are accessing. It is an external variable. That external variable is used in our program. So you cannot redefine the content. If you redefine the value, it will give some error message. With the extern specifier, the variable cannot be initialized. It is defined elsewhere. This variable is part of some other program, and that program value is used in the new program. So we cannot redefine the value of x. Say simply we are declaring an external variable. That variable is printed. We cannot modify, we cannot do any changes, or we cannot reinitialize. So that is external variable or external variable. The third type is called static. The static specifier gives you a declaration variable, static storage class. Static means we already studied constants and variables. Constant means the value is fixed. Its value is fixed throughout the program. We cannot change it. And we have static and dynamic variables. Static means it is fixed. Dynamic means it changes its value during the execution or based on the current value. Storage variables can be used within function or file. Unlike global variables, static variables are not visible outside the function or file, but they maintain their values between the calls. So the static variables will be declared and defined within the program. Its value will be available in the main program, in the function, as well as in the files. And it's not an external variable. It is part of the program. The static specifier has different effects upon local and global variables. If the variable is a local variable and it is of static type, its lifetime is within the block. If the variable is a static variable, it is a global variable declared above the main program. The lifetime is within the main program, within the function, as well as in the files. If you are using any file, the value will be stored in the files for a long time. Say how we can make use of static variables means, say here we are saying static demo, and we have a static variable int I. It is of type static type, and we are assigning static int I equal to 1, printf I. So here it will display the value of I as 1. Then we are incrementing, so the value will be increased. Again we are assigning the value as 1. We are incrementing post increment as well as we reassigning to 1. So once you come out from this block, what it will display, again we are displaying the value of I, and I++ get ch. In the main program we are calling the static demo 2 times. So the static demo is our function. It starts here, it ends here. Within the function we are reassigning the value of I 2 times, and we are displaying the value for 2 times. And in the main program we are calling it for 2 times. So what will happen, for example, the following program code defines static variable I at 2 places. So we are defining one place, again we are defining the value in another place. So here static int I, again static int I, 2 places in the static demo function. Function static demo is called twice within the main program. So in the main program also we are calling it twice. During the second call, static variable retains their old values and they are not able to initialize again in the second call of static demo. So while calling the first time, the control will transfer here. Its value will be initially 1. It will display the value of percentage %d I as 1. Then we are incrementing the value. So it will go here. There is no condition checking. It will come out and it will display the value as I, because the block, the scope is within this to this. So once you come out from this, within this block, the value is 1. Once you come out from this opening and closing bracket, the value is here, no initial value. So the value here is 0. By default, initial value is 0. So it will, while displaying outside this block, here this to this, the value of I will be 0 here. So it will display 0. Again, we are post incrementing I++. So it will, after post increment, it will get ch, it will come out from the function and it will go to here. Again, here we are calling the same function. So again, it will go there. Now the initial value is already we incremented. Value is 1. Again, we incremented I++. The initial value will be now 2. So it will display 2. Again, after displaying 2, it will come out. Here, within this block, the value will be 1 because it not yet decremented. So the previous value 1 will be displayed. So based on the definition, based on the position where it is, the position value as well as in the block location, it displays the current value of the I. So that is about static. Static means it is the scope is within the block and it will be visible within the block alone and it will change its value during the processing. Any doubt with respect to the static? So we will see the example program for static. See, previously we saw this one. Now we will see the extend variable. The screen compiler is visible to you. Compiler is visible to you.
Yes, ma'am.
Yeah, we are demonstrating the storage class extend. So extend int x1, int main, it is an external variable. Simply we are saying x1. Here just we are declaring a variable x1. It means that the variable is of extend storage type. So the initial value and the current value is, this variable is not part of this program. It is an external variable. We are using the external variable in our program. So the value of this is unknown. The previous value what is assigned to x1 will be used here. So here the previous semester marks or a previous semester calculation is used in the current program. So the variable is an external variable. So no initial value, the old value will be preserved. We cannot define or redefine the value. And simply we are displaying the content of external variable x1 and it will take the current value. So if you display, it's showing you the external value is 10. If you change the value to 50, because the variable is said it's the value of variable is x1 is an external variable, its value is saved somewhere. If you say change it to 50, it's displaying 50. Or if you change it to 550, so here it is an external variable. It will take preserve the old value. After executing this value will be assigned, and that value is displaying. So external variable means it is an external variable accessed from some other program. The same way, screen is visible now to you.
Yes, ma'am.
Yeah, this is an example program for storage class of static variable. So just now we saw static means it is an local variable or it may be a global variable. Local variable means the variable will be visible, lifetime, scope will be within the opening and closing. So whatever value, current value assigned to the variable, that value will be taken for, that value will be the lifetime of the variable will be within the opening and closing brackets. And the same way, this opening and closing brackets, so this will be the value. And within this block, we are separating the blocks by using the opening and closing brackets. So this is our innermost block and the second outermost block. So whatever value is available within that block, that will be taken for the variable. So if you run the program, so here its initial value is 0. We are redefining the value to 1. We are displaying the value. So it displaying the current value as 1. Once it comes out from this block, the value is 0. So that is showing here while displaying, it shows the 0. Again, second time we are calling the same function. While executing the second time, the previous value, this plus plus, because of this plus plus post increment, the value is increased from 1 to 2. So the current value is displayed while executing this block. And the second time. So once you come out from this block, the value is old value, 1 will be displayed. Or if you remove this, it will display the 1 and 0 alone. 1 and 0 alone it will display. Or if you remove any one block, say if you remove the this reassignment, then it will display the same value. Because here this variable is not declared. Say if you say this value is here, because we have the block, so you are blocking this. Here you should not call this, because the life is within this block. If you have this declaration, then only this will function. So if you execute this, now it will display outside also. Here you should not use. When the variable is declared, then only we can make use. So if you block these two, the current value alone is displayed 1. Or if you call the same function twice in the main program, only that this code alone will be executed. So it will display the result as 1 and 2. If you call one more time, it will display 1, 2, 3. So the value is visible. Visible means we can see. Lifetime means that is alive. And scope means that can be accessed and processed. So everything is fixed within the opening and closing brackets, or within the block, or within the function. So you got the idea? So far we discussed about what is union, what is the union, difference between static structure and union, how the memory is allotted. Then we saw what the storage classes, auto, static, external. So the fourth storage class is called a register. So register means you might have studied in digital logic design or compilers, as well as in what is that, computer organization, CPU, processing, memory allocation, dynamic memory, static memory, as well as physical memory space, logical memory space. In a compiler design, computer organization, you might have studied the registers, microprocessor, A register, B register, C register, and 8-bit register, 16-bit register, 32-bit register, 64-bit registers based on the processor. 80, 80, 80, 81, 81, 86, 286, Pentium core, dual core, all those things. So it's the memory locations used within the microprocessor, or in the RAM, random access memory, and read-only memory. So the register, memory registers, compiler and microprocessor registers can be used in our C programming. That's what we are saying. C is a system programming language. It's not an application program, system program. By using C program, we can create new programs also. Say by using C only, we created C++. We created a Python programming by using C only. The Python compiler is written by using C programming. C++ compiler is written by using C programming. And Visual Basic, Visual C++, Oracle, everything is written by using C programming. So C is a system program as well as application program. So here, how we can make use of registers in our programming means, in the main program, we are using the keyword register followed by int I. So the variable I is of register type. So the variable I will be stored in any one of the register. The register may be accumulator register or a base register or counter register or data register. In general, it may be stored in the data register, D register, but the variable name is I. The value 10 will be stored. Then we are declaring a pointer variable star p, and the star p takes the address of I. So the integer variable I of register type address will be stored in the pointer. Then we are displaying star p. So the star p means the content of p, 10 will be displayed. Printf address of I, p. So if you say p, the memory location where the 10 is stored will be displayed, and it is of register type. So what it will display in the following piece of code is trying to get the address of the variable I, because we are displaying p. So the p is the address. It will try to access the address of the I. It is declared as register. Therefore, the following piece of code won't compile and exit with error message. The address is of register is variable, because we are using the register, accumulator register or B register in our program. So it will display an error message. So you got the program. We are declaring an integer variable I with a constant value 10. The storage access specifier is register. It means the variable is stored in the register address, register memory location. And this register memory location address is stored in a pointer variable. If you try to display P, the register's memory should be accessed. But accessing the register's memory can be done by using mnemonics or microprocessor code. So it will display an error message. You got the idea? Any doubt with respect to? So if you execute the program won't execute. So where the screen is visible to you? Screen is visible to you?
Yes, ma'am.
Yeah, we have taken the storage class register example. So in this example, since there is an attempt to store the address of registered variable, it is a compiler error. Say here what we are doing, we have main program. Our variable int ia is takes the value 10. It is of register type. Then the pointer variable takes the address of integer variable. We are displaying p star p1. So the content of p1 is 10. If you say p address of p, it is in the register. So what it will do, it will show some error message, because we are trying to access the register. So if you remove the register, if you say, it will display you the value. So it's showing the value of a is 10. Value of address is the memory location address. So the value of IA is 10 and address is the memory location address. If you make the variable as register type, accessing the register address through C programming, it will take any RAM address. So the RAM address we cannot access by using normal programming. We need to go for programs with deals with the mnemonics and microprocessor instruction. Or if you say instead of star P1, if you say address of P1, if it is not a register variable, normal variable, so it's displaying the address. But if it is a register variable, that register variable address is it is based on the RAM and ROM address. RAM and ROM address simply we cannot access. We need to write microprocessor instructions and other mnemonics with so many other components. Then only we can access the register, because it is a permanent address. Maybe some secret code may be stored. So it is internal programming. It's based on operating system based. So you got the idea? Any doubt with respect to register memory address? So far we discussed structures and unions, how we saw and program with union, then the difference between structure and union, then the storage classes, auto, extern, static, and register. Four types of storage locations, or 4 types of variable storages. It may be an automatic variable. We should use auto keyword. If you won't specify auto keyword, by default the variables whatever we are using is automatic only, auto. If you want to make it the variable as static one, we should use the keyword static. If you want to make use of an external variable, we can use the keyword external. So if you use the access specifiers, storage class access specifiers, the lifetime accessibility, visibility will be fixed based on the storage class, whether it is automatic or external or register type. So the next subheading is called preprocessor directives. Already we used preprocessor statements to include the header files, to include the standard input output operations we are using stdio.h. For console input output operations we are using con.io.h. String operations we are using string.h. File operations we'll use files.h. Mathematical operations will use math.h. They are all preprocessor directives. Wherever we use hash define, it means we are using an header file. So the same way the C preprocessor executes before a program. So whatever you declare by using hash define, that will be executed first, then it will execute your main program. The preprocessor directives begin with hash symbol. Wherever you use hash, we'll use hash define or hash if, anything we can use. So we have 4 types of preprocessor directives. One is file inclusion directives. If you want to include any header file, we will include hash include. So the PPT screen is visible to you. We'll include hash include. Or if you want to define any constant value, we'll use hash define. Say we can say hash define maximum mark is 100, hash define internal marks is 30, hash define attendance mark is 5. So wherever the attendance mark comes, the value 5 will be substituted. Or if you say hash define pi equal to 3.14, wherever we use the variable pi, 3.14 will be substituted. The same way we can make use of the preprocessor directives for conditional checking. If maximum mark is greater than 80, then A grade. If maximum mark is greater than 95, S++ grade, like that. The same way we can have hash if or hash else if, or we can use hash else or hash end if, hash if defined, hash if not defined, if undefined. So these tags can be used before our main program. And the same way we can use miscellaneous directives like as programmer, as error, hash line. So if an error condition occurs, go to some other, display some message. If an a line keyword is found, display some message. If an program appears in your label, then display this message. So these miscellaneous directives can be used anywhere to display some interactive messages or to display some default values. The operators which we can use along with the preprocessor are, we can use one hash symbol or we can make use of 2 hash symbols. The PPT screen is visible to you?
Yes, ma'am.
Yeah. If you take how we can make use of these symbols means, if you say hash define identifier, identifier means here it may be pi or maximum marks, total, grade. Say hash define grade equal to C, then say hash define grade equal to S plus plus, first class with a distinction, or S plus plus means uh, graduated with honors. Hash define, hash undefined, some identifier. If the variable is not defined and that variable is appearing, in that case you display some message. And if an expression C equal to A plus B comes, then you substitute this value. Or if an n factorial appears, if expression n factorial appears, there you substitute the value as n into n minus 1 factorial. Or if expression 0 factorial appears, 0 factorial is 1. So the substitution can be done. Whatever we are putting in the hash define, that will be substituted because it is processed and it is ready to use. Say in our creating a cake, what we will do? So we'll use the milkmaid, so that the sweeten and the milk, everything will be added. Or we will take the ready-made mix. Just we will mix the ready-made content, just to boil or just to cook or just to bake. We'll get the complete recipe. So it is ready to cook, or is it made easy kind of. It is pre-processed and it is ready to use as it is in your program. And the same way we can have else. If the previous if or else if expression is false, then the compiler compiles the following section. If the if statement and else if statement both are false, in that case it will come and execute this particular else part. The same way end if marks the end of the if construct. If some if statement is used in your program, but you are failing to mention end if, in the end if once in the end if is found, it will display some constant message, end of the program, the process is terminated, you are complete successfully done your process. So some default information will be, it is ready made message that will be, say when you are not in office, in your email, what you will do, you are in vacation. Whenever you receive some mail, it will send some default message. The person is in leave. The person is on not in office. He will resume back after his winter vacation. So after he return back from winter vacation, he will contact you. Like that, we can give some default information. The same way, we can have end region name, marks the end of the region of the code, as no compilation effect. In the same way, warning message displays a compile time warning message. So say while compiling your program, so many errors are there. So the instructions are not as per the syntax and semantics, then it will automatically display the warning message and error message. Display a compile term error message when it come across any compilation error. Line indicator changes the line numbers displayed in compiler message. If the line numbers are swapped, or if it is there is some interlocking, or if there is one line execution is waiting for another process to complete, if it is a nested structure or indefinite loops, if the for loop is not ending, if the condition is not terminating, so in that case it will go for the default message. Programmer text specifies information about the program context. So here it will say this code is for so and so process. This process will be repeated for this much time. Say if you are reloading your program, or if your system is hanged, so it will display some message. It is rebooting. Wait for some time. Do not switch off the system. So those kind of information, default information or pre-processed information, can be displayed by using the preprocessor directives. So these are some of the examples. Okay, all of you answer your attendance. So for your understanding purpose, I added a easy slide, some simple slides that I will share with you, so that you can easily understand what is what. All of you answer your attendance. So we go through the topics, the differences between structure and union, the four storage classes, like say auto, static, register, and extern, their lifetime, scope, and visibility, and where and all we can make use, what is the default condition, then what is preprocessor directives. Actually, the preprocessor directives will be executed before the program starts. So we'll have the C code, the C program is written. If there is any preprocessor statements that will be executed, those values will be kept ready. Then it will go on to compile your program, link your program, then it will execute. While executing, the preprocessor directives will be substituted as it is. It's like built-in softwares or built-in, say we are using header files. The header files, all the say string operations you are including, say string reverse, string length, string concatenation, substring, reversing the string, palindrome, all those functions are already predefined and available in the string.h. So if you include string.h in your program, we can make use of all the strrev, strcat, strlen. So all those things we can ready-made built-in functions we can make use. The same way if you include math.h, the mathematical functions sine, cos, tan, cosine, square root, absolute, modulus. So those things we can make use. The same way if you use a preprocessor, your efficiency will automatically increase. Your program execution will increase. So you go through the content. If you have any doubt, ask me in the next class. And your OET through 3 is on 12th. Already shared with you your OET 1 and OET 2 marks. And OET 3 is optional or compulsory? Your OET 3 is on 12th, I think Saturday. The portion is module 4 and module 5. Already I shared with you your OET 1 and OET 2 marks. We will consider the best of 2 marks. So out of OET 1, 2, 3, marks from best 2 exams will be considered for calculating IA marks. From IA 1, 10 marks, IA 2 or 3, 10 marks, assignment and quizzes. Assignment and quizzes 5 marks, and the MCQ. Already you have, in your OET 1, 2, you have MCQ for 10 marks, now that 5 marks. So total OET 1, 2, 3, 10 plus 10 marks. MCQ from OET 1, 2, 3, 5 marks. Assignment 5 marks. Total 30 marks. If your marks in OET 1, 2 is less, you can try OET 3 so that you can get maximum marks. So you go through the topics. Once again, we will revise the same in the next class also. I think Thursday you have class. This additional material I added that I will share with you, and I will share you some sample code also. And for your OET 2 also, the questions from your syllabus, from your material, the programs which you did in your lab example programs, the same will be asked. Okay, any doubt?
No, ma'am.
If no more doubts, we'll end the class. We'll have class on Thursday, 9:45 to 10:45. That time you go through the module 4 and 5. If you have any doubt in 4, you ask me, we will revise. If you have any doubt in 5, you can ask me, we'll revise. Otherwise, once again, we will revise the structures, unions, the differences between structure and union, the storage classes, auto, static, extern, and register, Then the preprocessor directives. Whatever we discussed today, we will discuss with additional programs and additional explanation so that you can easily understand. So if you remember this table, you can understand where it is declared, how long it can be used, and what is the lifetime. Usually this auto static extend, all those things are used while creating the compilers, while creating the C++ compiler or Python compiler, or creating any device drivers, say printer driver. If you are using pen drive, device driver will be installed. So while creating any new hardware or any software, we need a compiler, device drivers. Those system programs, hardware programming will be written by using C compiler. Okay, shall I end the meeting? If no more doubts today, we will end the meeting. We will revise once again on Thursday. So this preprocessor directive is your last topic. These are the slides I added for your reference. If you have any doubt in any particular topic, you can message me in my WhatsApp. That topic we will revise. Okay, shall I end the meeting?
Yes, ma'am.
Yeah, thank you.
Thank you, ma'am.